Hi everybody, in this video I'm going to present you with 5 amazing open source generative AI music models. And here you have the rules of engagement that I've used to select these models. First, they are both generative music systems in the symbolic and audio space. They all come with code and pre-trained models that you can use very easily, and they cover different types of generative music use cases. Another thing that I want to mention is that I'm not going to cover the technical aspects of these models in detail. That's not the point of this video. I just want to give you an overview of these models and where you can find them. Okay, so what are these models good for? Well, for a number of reasons, but specifically if you are trying to build an AI music system or a generative music system, some of these models can help you get started super fast. You can plug and play them, you can use them for fast prototyping, or you can even fine-tune some of these pre-trained models to come up with a system that works really, really well for you. Now, what's the first model that I have in mind? Well, it comes from Meta as part of a release called AudioCraft. AudioCraft has 2 models. One is called MusicGen, the other one is called AudioGen. MusicGen does text to music, AudioGen, you guess it, does text to audio. Of course, we're going to be focusing on MusicGen, but what I'm saying for MusicGen basically is also true for AudioGen, at least in terms of like the technical and architectural aspects. So MusicGen does text to music, which basically means you come up with a text input, free-form text like the one we have in this example, so lo-fi song with organic samples, saxophone solo. You feed that into the model and the model comes up with a music output that's directly an audio file. Now let's take a look at MusicGen's architecture. This is quite complex. I'm going to keep it super simple. So in essence, what happens is that you come up with an audio input, then this audio input gets passed through an encoder, and the result is that you have a series of encoded tokens, and these are discrete audio tokens. Now, when MusicGen generates new music, what it does, it basically generates a sequence of discrete audio tokens using a decoder language model that's made up of, its architecture is basically like a transformer. So it generates a sequence of audio tokens and then it converts them into full audio so that you can get like the audio at the end. You can condition this generation on a text input, and here's the text to music aspect of it, or you can condition that also on an audio input. So basically you can hum a melody and get back a piece of music that is basically built around that melody that you've hummed or you've created somehow. Now let's jump into MusicGen's companion website. So here you have a bunch of demo tracks and I'm going to play a couple for you. So let's play this one. It's a pop dance track with catchy melodies. Let's listen to this. You get the gist of it. Now let's listen to this other one. So a grand orchestral arrangement with thunderous percussion, epic brass, fanfares, and so on and so forth. Yeah, very Hollywood-like. Okay, let's go back. Let's take a look at some of MusicGen's characteristics. First, MusicGen is available in transformers. That's a Python library directly from Hugging Face. What this means is that it is extremely easy to play around with and to integrate. MusicGen comes in different sizes. From the smallest size is a model with 300 million parameters, and the largest one has 3.3 billion parameters. What this means is that you can actually use MusicGen on a decent GPU, but you don't need monstrous GPU power to run it. With MusicGen, you have code for training and for fine-tuning and of course like for doing inference. The great thing about MusicGen is that it comes with an MIT license that's very permissive. You can use it for commercial purposes, but the kicker here is that you can only use MusicGen commercially if you use the code, not the pre-trained models. So these pre-trained models you can use, but for non-commercial purposes only. Okay, now let's take a look at MusicGen's GitHub here. And here you have all you need to understand how to use MusicGen. I think you also have an API here. And down here you have code and sample code like for training and for doing inference. MusicGen has some limitations. First of all, it can generate only 30-second snippets of music, which basically means that if you want to generate a full piece of music, you can't really use MusicGen by itself. Vocals are also quite bad, and you have limited control, because the only control you really have is the input, the text input that you can feed into the model, or the melody, right? But with all of that said, I think MusicGen is great for text to music and for melody condition generation, and you could think of using MusicGen in the context of a consumer app where you are targeting non-musicians, non-professionals who are super happy to have something that works, music that they can create through a simple text input without the need of having extra level of control. Let's move on to generative music model number 2, and that is called MuseCoco, developed by Microsoft. This is an extremely interesting model. It's made up of 2 sub-models. It's basically a text to music model, and it actually generates a symbolic score, so it's not audio, it's just symbolic. But it works into 2 steps, and at each of these steps you have a separate model. So you start with a free-form input text, just like MusicGen. In this case, in this diagram, we have this example. So this pop music comes alive with the dynamic blend of the grand piano, organ, guitar, bass, and drums, and so on and so forth. Now, we feed that free-form input text into a model that does text to attribute understanding. So this is a natural language processing model that takes a free form description and it converts it into a fixed series of musical attributes. What are these musical attributes? Well, you can see them here. So these are the different instruments, time signature, tempo, pitch, genre, and so on and so forth. I believe that they have more than this. So we start with a free-form piece of content, and then we convert that into a series of musical attributes, and we use these musical attributes and we feed them into this attribute to music generation model that actually generates a multi-track piece of music, and that is in a MIDI format. It's in a symbolic format, so basically it's a score. Okay, so what about this attribute to music generation model? So what's its architecture? Well, you can guess it, it's a transformer model. Okay, now let's jump into MuseCoco. This is the companion website to the paper, and I just want to share with you an example of this model in action. So yeah, group 7. So here you have the text description. You can read it while I'm gonna run the generated music for you. So it's an upbeat piano piece. Now let's go back to the presentation. MuseCoco is implemented in PyTorch. It comes into different sizes. The smallest has 200 million parameters, the largest 1.2 billion. You have code for both train and inference. And the great thing about it is that it comes with an MIT license, which basically means you can use it for whatever reason you want, also commercial reasons. Now let's jump into MuseCoco GitHub. And again, this is a very well organized GitHub. You have all the information you need about the different attributes, how you can train the model, and you can train both models, right? So the text to attribute and the attribute to music generation. And here you have information about inference. Obviously, MuseCoco comes with some limitations. It doesn't have any audio output because, as I said, it generates a symbolic score, which basically means that it has an inherent poor production quality, because at the end of the day, it's just like symbols. And symbolic generation, as we know, doesn't work with all genres, especially with those genres where production takes the lion's share. Think of like some EDM styles or electroacoustic music where it's all about production and sound. So how can you sort of like synthesize that in a score? You can't. And so those genres are not a great fit for a symbolic model like MuseCoco. Another point about MuseCoco is that it has some limited amount of control. Of course, you have more control than MusicGen because you can play around with the attributes specifically, or you can also play around with the MIDI that's generated by MuseCoco, but it's still quite difficult to decide to constrain the generation, or for example, doing things like in-painting or out-painting like with MuseCoco. You can't really do that. But regardless of such limitations, MuseCoco, I think, would be a fantastic help as a composer co-pilot. So basically, it's a system that you can use to help you get ideas and inspirations for your music creation activity. And it would definitely be like very useful for amateur composers and musicians. The third model also comes from Microsoft, and it's called Museformer. This is quite similar to MuseCoco, but it has a different spin. Again, it's a symbolic model that generates basically like MIDI scores. It can generate full tracks. It's based off of a transformer architecture, but here's the kicker. So Museformer comes with two types of attentions. So one is called like fine-grained attention, and the other one is coarse-grained attention. So basically they use like two types of attentions because by doing so, they enable Museformer to establish longer-term relationship within the music, which basically means all of this approach makes it possible for Museformer to generate music that has better form, better structure, longer musical form that's still more coherent. This is one of the major issues that we have with generative music these days. It's basically like coherence across like longer pieces of music, and Museformer tries to tackle that using this double type of attention. Now let's listen to an example of Museformer. Again, we are in Museformer's companion website, and we're going to listen to this demo here. Okay, let's move on. Okay, so we have this nice string pad, and then, yeah, let's move on. Yeah, the piece, as you can see, is quite long. It's more than 3 minutes. And if you go for it, you'll listen that there are phrases that are coherent, and there's an overall sense of musical structure in different sections that work like relatively or quite well together. Okay, so I'm not going to go through all of these 3 minutes, but you can do that. And by the way, I'm going to put all the links that you see like I'm using here in the description box so that you can have easy access to all of these models. Researchers trained Museformer on the LAC MIDI dataset. It's a gazillion amount of MIDI files. They've used NVIDIA V100 GPUs with 32 gigabytes of memory, so that you get an idea of the type of GPUs that you'll need to train this model. You have code for both doing training and inference, and again, Museformer comes with a very nice and permissive MIT license. Here you have Museformer's GitHub, and again, here you have all the necessary information for training the model, for evaluating the model, and for doing inference. The issues with Museformer are quite similar to the ones that we saw with MuseCoco. There's no audio output, And the reason is because this is a symbolic model, and it doesn't work with all genres. Same reason as we had with MuseCoco, because there are a bunch of genres that put production first, and with a symbolic generative model you can't capture all of these production nuances. And there isn't necessarily a lot of like manual control that you can do, and that's a little bit of a problem. But again, you can use Museformer as a sort of like composer copilot to allow amateur composers and musicians just to get ideas and inspirations directly like from a machine. If you're a founder, tech executive, or engineer building an AI music system, I understand your challenges. You might be unsure about where to begin. You could be questioning whether your AI music concept is even viable, or which techniques would be best to bring your vision to life. Maybe you're looking for someone who can transform your idea into a reality. The truth is, developing AI music products is difficult, and the skills required are both highly specialized and scarce. However, it doesn't have to be this complicated. I offer consulting services that assist with strategizing and development of AI music products from concept all the way to market. I also provide a free clarity call to help strategize your next steps. So if you are in the process of building an AI music product and you need help, visit the Sound of AI consulting website to book your free session. The link to the website is in the description box below. Now let's get back to the video. With the 4 model, we go back to the audio generation space, and this model is called RAVE, and it's been developed by Earcam. This is a neural synthesizer. It uses a variational autoencoder architecture, and it's basically a real-time audio synthesizer. Now, RAVE, it's a quite cool model. I've used it like for a long time. You have all the necessary code for training, for inference, and there's a great feature about it is that it has an integration with MaxMSP and Pure Data so that you can use it in real time during a live performance, and it's super cool. It also comes with a VST so that you can directly use the model without any technical knowledge within your DAW, Cubase, Pro Tools, what have you. And at the end of the day, what RAVE does is synthesis, audio manipulation, and timbre transfer. Again, you have an amazing GitHub page for RAVE, and yeah, you have like all the necessary information here in the code as well if you want to play around with it. Let me show you RAVE in action. So there's this nice demo video. It's a minute, a little bit more than a minute, and we'll go through some of it. So you'll see different use cases. So the first one, I believe, if I remember correctly, is timbre transfer. So you have this sound initially, and now you have like this timbre transfer effect. Yeah, that's just neural audio synthesis for you. I think like this drumming sound. And you can also play around with the latent space within the encoder-decoder architecture, variational autoencoder architecture, to morph the sound, which is actually quite cool. And all of this is happening within MaxMSP, I believe, so it's all in real time. Really, really cool stuff. In my experience with RAVE, it's sometimes difficult to train, and it's sometimes to get really good sounding output. And another major limitation is that it has a non-commercial license, which is a little bit limiting. But RAVE is a fantastic model for live performances. I love it, and for audio processing in general, and I really, really suggest it to all musicians out there. The 5th and final model that I want to present you, folks, is not really a generative music model. It's more than that. It's a music agent, and that's another piece of research that comes from Microsoft. They're really killing it at Microsoft, I have to say. And I really suggest you go check out the MusicAgent article. It's very well written. It's a lovely piece of write-up here. Okay, so what's MusicAgent about? Well, this is a music agent. What this means is basically it wraps a lot of different AI music models, and you can interface with this music agent through text. You can request something through text, like for example, write a song about love, or perhaps analyze this song, or perhaps split this song into the different stems, and then that request is picked up by the agent that's divided into three main tools. So there's a task planner, there's a tool selector, and there's a generator. The task planner creates a plan that basically outlines a way of carrying out the request. So once we have basically a plan for carrying out the request, then the tool selector picks up the plan, and it basically selects all the necessary plugins to carry out that plan. And finally, the generator actually uses those tools to generate a response, and the response can come in different forms. It's multimodal really, because it can come in as text or as an audio file perhaps. Okay, now here you have the different components of MusicAgent so that we can understand a little bit better what MusicAgent is about. So here you have the applications, or as I prefer to call them, the different use cases, like create a song, analyze the music, timbre transfer, sound mixing, music transcription, and so on and so forth. Then you have a bunch of plugins that come from different environments, like from Hugging Face, from GitHub, from APIs like Spotify or Google APIs, or built-in functions and other things as well. And so here you basically have like all the different tools and plugins and models that the agent can leverage to carry out the initial request or a particular use case. And then you have all of these skills, and these are like the three different components that we saw in the previous slide. So the tool selector, the task planner that creates a plan, the tool selector that decides which plugins to use, and then the response generator that actually generates a response. And in the backend, you have a large language model. And so the large language model is sort of like the component that helps facilitating all the different processes. It's sort of like backend reasoning that you have behind this music agent. So yeah, this is a really, really cool idea. And here in particular, you can see all the different types of like plugins, like in use cases like that you have available within MusicAgent. Like for example, text to symbolic music, and they use MuseCoco for that, lyric to melody, singing voice synthesis, text to audio, and so on and so forth. Okay, now I want to show you the GitHub page for MusicAgent. Again, it's a very well organized, very instructive page, and down here, if I remember correctly, yeah, they also provide code to run MusicAgent with a Gradio interface, so you can play around with it. And if you're curious, you can also click here and you basically have a demo video for this. The main limitations of MusicAgent is its plugins limitations. Some of these plugins are quite powerful, others are quite limited. So MusicAgent inherits all of those limitations. I would definitely use MusicAgent to create a sort of advanced DAW where a user can leverage this intelligent agent to perhaps synthesize a new sound, or to come up with a new melody line, or to create some accompaniment, or to do some source separation. You can think of it as a sort of centralized music wizard that you can talk to through text interface, and then integrate that perhaps into a full-blown DAW. And this is a type of application that's perfect for musicians and music fans alike. These are 5 impressive generative music AI models, but they are quite advanced. If you want to learn a little bit more about generative music, I have a full playlist about it. It's a full course that starts from scratch all the way up to more advanced things. So I highly suggest you to start this course up here or somewhere in this screen. Take care for now. I'll see you next time.